Hello everyone. Today we will solve this LeetCode problem adding two numbers. So we are given two non-empty linked lists that represents two numbers, non-negative, and the digits in this linked list or the digits of these numbers are in reverse order. So for example, this 243 linked list, it represents the number 342, so it is the reverse order of the original number. And we are given two linked list. We just have to add them and return a linked list that will represent the summation of these two numbers, also in reverse order. Here, these two numbers, when added together, the result is 807, and the linked list will be in reverse order, so it will be 7, 0, and 8. So this is the linked list we need to return. So the original task, just adding two numbers, are very simple, but it's in a linked list. That's why we need to be a little bit careful. Okay, let's revisit the addition of two numbers, how we can add two numbers. So let's start with this example. So we have given two numbers, 3 4 2 and 465. So if we sum them together, we have 2 and 5, that is 7, 4 6. So the sum is 10. We this 0 will be here, and the 1, it will be the carry. So carry 1 will go here. So this carry, the other 3 and 4 altogether, it will be 8. So this is the result. So now imagine that we have another digit here, let's say 4. So that means we need to keep doing this operation until any of these lists are complete. So will do the next position in this number, that is 4. There will be, okay, no carry, so this 4, and here there is nothing in this list, so we can consider it as 0. So 4 and 0, it will be 4. So that will be results. Another scenario can happen is that instead of 4, let's say this is okay, let's say instead of 3, here we have 7. So let's redo the summation. We have 4, so 2 and 5 7, 4 6 0. There will be carry 1, this carry, and 7 and 4, that is 12. We have 2, and there will be another carry, that is 1. So this one, and in these two positions we don't have anything, so we can consider them as 0. So 1 0 0 will have 1. So we can see that there is a pattern, that if there is any element in any of the linked list, or there is any carry, then we will have to keep adding those uh, them, and consider the other as 0. So that's it. Like, if we just keep that in mind, we'll be able to perform this summation of any two linked list. So let's start writing the code. So the condition is that if we have L1 or L2, so if there is any element in L1 or L2 or carry, so let's define the carry initially as 0. So if we have L1 or L2 or carry, then we need to keep performing this operation. So now at this point, sometimes L1 might be empty, none, like it doesn't have any more elements. Sometimes L2 might not have any elements, and sometimes carry might be 0 or a number. So we need to consider them, especially the L1 and L2. So let's say we have L1. So if L1, then we will have a value L1 dot val. This will be our one of the three numbers A. So L1 dot value, if we have L1, otherwise we will have 0. Similarly, the other number B, it will be L2 dot val. If we have L2, this means that L2 is not none, which means that there is an digit, or at least one digit in that L2 list. So if we have L2, then we take that L2 value, otherwise it will be considered as 0. Carry, it can be 0 or a number, that doesn't matter because we can just add 0 because it's by default 0. So now we need to sum them together. So sum A, B and carry. So this function, right now we don't have this function. Let's define it. Sum A, B and carry. So we are not implementing it right now, we will implement it later. So this will result in the sum of these three numbers and carry of, if there is any carry. So if there is nothing, no carry, then it will be 0. So uh, this is the line where the actual summation happens. Now after this operation, we need to go to the next digit. So next digit, that means we have to advance the L1 to the next position. So L1 will be L1 dot next. Similarly, L2 will be L2 dot next. However, L1 or L2, they might be sometimes none. That means the next will not be accessible if L1 is null. So we need to add that condition. So if L1, then we have this L1 dot next. Otherwise, we will have none as the value for L1. Similarly, if L2, then L2 dot next. Otherwise, it will be none. So these two lines will ensure that we are advancing to the next position. These three lines, these are just adding this the digits at that position. Now we need to construct the list so that we at the end we can return that linked list. So here we will have a, this is a element, so let's a list node element, and it's created by the sum value, so s, and we need to add this summation element to a list, but right now we haven't defined any list. So let's say we have a list and there is a pointer for previous. So the previous element, it now points to the this current summation. So previous dot next will be our current summation. Now let's go back to the previous, how previous is going to be updated. So initially, let's say previous was null, none, so nothing. Initially we don't have any previous value, and when we add those numbers, we update the previous dot next to this current node, and previous will be updated to previous dot next. That means previous will also be advancing to the next digits. So let's describe here how actually it. So we have, So let's see what's happening here. So we're assuming that there is a variable p previous, and this is our summation, current sum, and its next value is this current sum. Now when we will calculate the next position, so is, let's say 1, and this will be 2. When we will calculate 2, the previous will now point to here, so this will be our previous, and this will point to this s2. Similarly, when we will calculate s3, this will be treated as previous and its next will be s3. So that's why the previous next will be our current summation, and the previous will be updated to previous dot next. That means this current. So this will be our new previous. So now we need to, here, if we set it as none initially, then that means we have to check if previous is none or not. If none, that means we cannot do this operation directly. So to avoid that, we will initially set a dummy node as previous, and that dummy node will be our uh, a instance of list node. So it is just a dummy node. It will not be part of the final result, but we start from this dummy node so that we don't have to check if previous is none or not, because previous will not be none. It is started as a dummy node. Now at the end of this loop, we have performed all the summation of all the digits. Now we just need to return the result. So the result will be the node that is pointed by dummy. That means we are just excluding dummy, and the next element of dummy from that point up onward, this will be our result. So let's run this code. Oh, one thing, the sum, we haven't implemented it yet. So it will be s, so let's say value b will be a plus b plus carry, and the sum will be b mod 10. Sorry, b mod 10. So it will be our sum, and the carry will be b divided by 10, integer division, and we just return yes and carry. So now run this program, all case passed, submit it, accepted. So that's all of this code. Hopefully it was helpful. Thank you.